this video, we will continue with the iterative process. You will find this on page 561 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. Let's look at another example. By sketching a suitable pair of graphs, show that the equation cos x equals 2 minus 2x, where x is in radians, very important, has only one root between 0 up to a half pi. Okay, now the nice thing, because it's included there, I can start and just get the middle one. And then just press, make sure you put your calculator on radians and just press it in. And then just get that values. Then the same 1 and 0. So because this is just going to be where it cuts the y-axis, where it cuts the x-axis. So you have your graph. Now, there are only one point of intersection. So there are only one root. So verify by okay, that has only one real. So you have to do the sketch. Now, let's go on. Now, if you look at this one, I say verify by calculation that this root lies between 0.5 and 1. So I'm basically just take this, remember this is now equal to each other, like this, and I just bring this one over, okay. So I'm just putting it everything to one side and I create this combined equation. And then I substitute and I get a negative value, take note. And then I substitute the 1, so it's between this two, and I get a positive value. Then, the change of sign indicates the presence of a root between 0.5 and 1. Okay, and x is 1. Then we go on. Show that a sequence of values given by the iterative formula, this, converge to the root of the equation in part A. Okay, so basically, I'm taking this, remember, I'm taking this one they gave, and I see if I can go back to the original one. Now, the original one was this. So if I write this, I'm going to start, and I'm just going to simplify and make a cos, see if I get this cos, where is it, cos x. So first, this is this, and then I just get rid of the fraction, so the 2 that I multiply 2, and then I take the cos over and I take this one, and if, as you can see, it's exactly the same as that. Okay, and then use this iterative formula with initial value 0.6, so they tell you, so use that one, start with that one. To determine this root, correct to 2 decimal places. Give the results of each iteration to 4 decimal places. Okay, remember how did we do that in previous? We're going to first put this in the memory. So we're going to say 0.6 equal. Now it's in the memory. Now we're going to press 1 minus, you can put a bracket. So bracket, if you want, 1 divide 2 multiply cos answer, close the bracket. And then you just press equal. And then you get x2. Make it 4 decimal places and then approximate also to the 2. Okay. And then again equal, and I get 4 and then 2. And I'm look until I get this to the same. And then I stop and I say correct to 2 decimal places, the root converges to 0.5. Okay. I want to show you another thing. Okay. So actually this, but let's first go. We can prove the root correct to 2 decimal places using the sign test. In example 8, the root seems to be, okay, 0.5, correct to 2 decimal places. We can prove this using a change of sign test. Okay, so if we're going to say, okay, the root is between, we take 0.58, but we take the before, do you see, and a little bit behind. So we actually prove that that's the root. So a little bit before, I get negative. And a little bit behind, I get positive. So the change of sign indicates the presence of a root. Therefore, 0.58, correct to 2 decimal places, is the root. Okay. But I want you to look at this. When you use the iterative formula and draw the 2 graphs, okay, on the same grid, you will notice that the pattern of converge is different in this example than the previous one I showed, or previous examples. This type of converse is called the staircase pattern. Okay. Now, I'm first going to explain, and then I'll show you the difference, and I'll even go back to the previous one. Now, if you remember the previous one, the cop, then we went in the circle and we go closer and closer and closer. Okay, this one is not. This one, we not go in the circle, we come from a side, but we also go closer. Do you see? So there it is, and I just enlarge it there. Now note, if both gradients of the graphs are positive, now if you look at this, or negative, do you see this gradient is coming down, it's negative. This is also coming down, it's negative. So both is negative. Okay, that's what I mean, the gradients. So if both is either negative or positive, you get a staircase pattern. If the gradient, the one is positive and the other one is negative, you will get a cobweb pattern. And can I just show you a previous example, which we did? And I have to go a little bit back, sorry, quite a lot. Oh, there was it. There it was. If you look at this one, then this gradient, and I want to make it a bit bigger. Okay, so if you look at this graph, the gradient was positive, it's uphill. If you look at this graph, the gradient was negative because it's downhill. And then you get this pattern, the spiral, the cobweb. So it's going in the form of a circle. Otherwise, as I showed you, but then the gradients was opposite. The gradients are the same, then you get this staircase or zigzag pattern, just to take note of. Okay, I want you to stop the video. I always wish I did that line away. Oh, it's away. I want you to stop the video and I want you to do try now 8. Again, you can continue the video as soon as you are finished. Okay, let's start. I think, okay, there it is. Now, I say by sketching a suitable pair of graphs, show that there is only one value of x in the interval. Now, just take note, the 0 and the half pi is not included, which is a root of the equation cot x equals x. So there is your two graphs, y equals cot x and y equals x. Okay, now, always I start, so I'm going to start with A, and I'm first going to write it down, what they give me. The equation, and out of that equation I'm going to break it up. So it's y is equal to cot x and y is equal to x. Okay, that's what I'm going to do, and I'm going to draw that graphs, and I'm going to create a table. Now in this case, due to the fact that they don't say 0. Okay, I'm going to create it a little bit. Oh, let's just make it a bit longer. So I don't like it so short. Okay, make it just a little bit longer. Okay. Okay. Okay, let's start. So this is going to be my x. And this is my y. Now, because they tell me x is bigger, it's not included, to 0, and smaller to a half pi. Okay, so basically what I can do is I can, just to get a little bit more points, I can say, let's take a half and we divide it by 4. Okay, just to get, so if you're going to take a half, and you just divide it by 4, you're going to get, you can check it on your calculator, but it's 1 over 8. So if you divide it by 4, then I get 1 over 8. So let's make this 1 over 8 pi. And now I'm going to work in multiples. So this is going to be 2 over 8, but 2 over 8 is a quarter pi. And this is going to be 3 over 8 pi. Okay, so that's in between. It's very good that you already, and I said that, you must know, just like you must know the basic graphs of sin, cos, and tan, you must know the basic graphs of sec, cosec, and cot. And that comes from chapter 10. There at the summary you will find. Now, cot, if you can, so it's very good if you have this little picture in your mind with the, let's just go. With the cot, the other one is the use, okay, the sin and the cos. But with the cot, it's in the opposite, where the sin, where the normal graph of tan goes like this. This one is almost like in the opposite direction. It's doing something like that. Okay, so it's that little part that I'm going to get there. Just keep it in mind. Okay, now your calculator is on radians. So let's just press it in. Also remember that we don't work with, we are going to work with 1 over tan x. Okay, so it's going to be 1 over tan 1 over 8 pi. Okay, so let's just press 1 divide and then tan, where is tan? Just want to see if I'm on radians. Yes, looks like that. Tan, and then bracket 1 divide 8 multiply shift by close the bracket equals. And that is going to give me 2.4. And I write it in. Okay, and now I'm going to do the quarter exactly. And oh, that is very nice because it's 1. And then I do exactly the same for this one. So remember 1 divide tan bracket 3 divide 8 multiply pi, close the bracket, and I get 0.4. Okay. This one is very easy. Why? But let's keep to the same. So let's make it also 1 over 8 pi. And then it's a quarter pi. And it's 3 over 8. Okay, now just for the drawing, on the x-axis we will have these values, but on the y-axis we work with numbers. So just go and calculate this. Basically, just say 1 divide 8 equals multiply shift pi equals. Just get it in terms of values. And that will be 0.4 to 1 decimal place. The same, 1 divide 4 equals multiply shift pi equals. And this is 0.8. And then the same with this one, and this is 1.2. Then it's on my y-axis, I don't work in terms of pi. Okay. So now I'm going to get my grid. So let's just get the grid. Okay, now let's just move this up. Okay, we have that. Okay, I can first close that. Okay, and if I'm going to move this up, okay, and then it's more on the top, so it's just, this will work. I could make it just a little bit lower. I think this is better. Okay, so basically I'm going to just get, this is 0, and then I think I make it 2 that it's not too small, 1 over 8 pi, and then as it's going to be a quarter pi, I just want to see, it's 1 over 8 plus 1, yes, it's going to be all right. So it's 2 over 8. So it's a quarter pi, or 2 over 8, it's fine. And then it's going to be 3 over 8 pi. And this, I'm going to work with 0.5, 1, 1.5, 2, 2.5. Okay, okay. And then I'm going to plot my graph. So let's just start with, remember this one was just going to keep it yellow, x equals y. I'm just converting that pi to a number. Okay, so if I'm going to start with my, let's make this green. So it's 1 over 8 and it's 2.4. So 2.4 is approximately, oh yes, this must be green, 2.4. Okay, and then a quarter, and that is 1. And then 3 over 8, and that is 0.4. Okay, and then remember, you know that graph, it's coming from there, but it's fine because you can go closer. Just want to see. Okay, just remember that it's going to intersect there, but because not, you can just, it's just showing the root, so it's just going to go up to there. Okay. Now I'm going to do my yellow, so it's going to be 1 quarter, so it's 0.4, and then, okay, first 1 over 8, then a quarter, 0.8, and then 3 over 8, and it's 1.2. And then I'm going to take a ruler because it's a straight line. I know y0 is 0, and so it's going to just be something like that. Okay, and I can just name it. This is y is equal to x. Always label your graphs. And y is equal to, remember that was cot x. Okay, can you see it only intersect one time? Just for the interesting, will this be a staircase or will it be the zigzag? Not the zigzag. The staircase or the cobweb, that will be the cob, because that one is going to be negative and that one is going to be positive. Okay. Now, in this case, so that's going to be that cobweb, not the staircase as the previous one. Now, I'm just going to say, I'm just going to get my background again back. So, I'm just going to end up by saying, there is only, therefore, there is only one point of intersection, so the equation x is equal to cot x has only one root in, that's very important, in the interval x is bigger than 0 and smaller than y. And that's how I do that one. Okay, that's number A. So let's just go up. Don't forget, that was, did I mark it? I remember. Yes, it was A. Okay, let's go to number B. Verify by calculation that this root lies between 0. Okay, so just remember, this is very important, that you take this equation now. There is the equation. Okay, let's just show you. And that everything goes, it doesn't matter if it goes to this side or to this side. In my example, I was just taking it to that side, but it doesn't matter as long as you just work with the same. So I'm just going to start by saying B. And I'm going to say fx, and I decided to take it to that side now, but as I said, it doesn't really matter, as long as you keep to the same equation. Then I'm going to say f 0.8 equals cot 0.8 minus 0.8, and you're still on radians. And that is going to give you, so just press on your calculator, again, press it like that. I think it's easier to press it like that. But if you do the other way, you can also. So 1 divide tan 0.8 equals minus 0.8. And I get it's 0.171. Just take note, it's positive. Okay, and then I do the same. I say F, and now I go for 0.9. And that's cot 0.9 minus 0.9. And remember, it's again 1 over tan 0.9 minus 0.9. So 1 divide tan 0.9 equals minus 0.9, 3 significant figures. And it's minus 0.106. That's negative. And then I just end off by saying, therefore, the change of sign indicates the presence of a root between x is 0.8 and x is 0.9. Okay. Okay, and now I'm just going to go to number C. Now show, now I must do it here that I just can see also, and just draw a line. I just always like my line first. Okay, there it is. And then I can start with number C. Then show that the value of x is also a root of this equation. Okay, now if I start with the beginning, the value, the thing that they gave me, they said x is equal to cot x. So I must manipulate it to get this. Now how do I do this? So make it just like I said, 1 over tan x. And it's over 1. So I cross multiply, so I have actually x, tan x is equal to 1. So tan x is equal to 1 over x. Okay. And now I'm just going to show, you remember if I want to show the angle inverse functions, what we did in trigonometry also, then we're just going to say it like this. X, can you remember the angle? Then we write it like this. Tan, chapter 4, go and just check there, minus 1 over x. That we did in chapter 4, the inverse of this. I can actually refer you, if I just quickly going to check here in my textbook, I just want to see where we did that inverse. It's in chapter 4. And it's the last. It's here at the end. Oh, there I found it. You can go back to page 203. Inverse trigonometric functions. We're just going to page 2 if you just want to refresh your memory. But that's the way how we write if we're going to work out that angle. Okay, so now they say use the iterative formula to determine this root correct to 2 decimal, showing the results of each. So if they don't say 5 decimal places, or take it at least to 4, at least 2 more than that one. Okay, so let's just start. So now I'm going to go to that number D. And remember, did they tell me a beginning value? Let me just see no. If they did not tell me a value to start with, I'm going to go a little bit lower, and I'm going to see the root was between 0.8 and 0.9. So I can start with 0.85. So x1 is 0.85. And don't forget, now I'm going to say x, take that formula, n plus 1 is equal to tan minus 1 over xn. And don't forget that is fx. Okay, that's your fx formula. Okay, but we're doing it a little bit shorter now, as I said, because they're just going to focus on this. So go to your calculator, press 0.85 equals. It's in your memory. Now, can you remember that's how we write the angle? So we say shift tan, that's just meaning we must press shift tan for the angle, then bracket 1 divide, and that's the answer, and close the bracket, equals. And what do I get? I get 0.8663. I think if we make it 4, then it will be fine. And we approximate it to 0 to 2 decimal places. Just want to control to see if it was 2. Yes, 2. Do you see? 2 decimal places. So it's 0.87. And remember, just press equal. And now I get 0.8569. And again, it's 0.86. And then I press equal again. And then it's 0.8623. And then it's again 0.86. Oh, there, it's the same. Yes, it's the same. Okay. And so I just end by saying, therefore, correct to 2 decimal places, x is equal to 0.86. And that's how you do it.